Chess is an ancient game of strategy and skill, played by two players on a checkered board. The game is played by moving pieces around the board to capture the opponent's pieces and ultimately checkmate their king. Chess has been played for centuries, and it is believed to have originated in India in the 7th century. It remains a popular game today, played by both casual and competitive players around the world. Designing an algorithm to play chess has long been a goal of computer scientists. Let's see how different chess pieces move. A king can move one square in each direction. A queen can move any number of squares in each direction. A rook can move only in straight lines, again any number of squares. A bishop can move in diagonal lines. A knight can move in L-shaped moves. But of course, this is chess, so you probably already know the rules. The first known automaton to play chess was the Turk in 1769. But this was a cheat. The Turk was actually operated by a human and was thus not fully mechanical. Computer chess has been around since the 1950s, when scientists began to program computers to play the game. Early computers were not powerful enough to play at competitive level, but as technology advanced, so did the ability of computers to play chess. In 1997, a computer program named Deep Blue famously beat the world chess champion Garry Kasparov in a 6-game match. At that point, this was seen as one of the major achievements of artificial intelligence. Let's see how a simple chess playing algorithm works. The search tree algorithm is the most commonly used algorithm for computer chess. It is a brute force search of all possible moves. We use a rule-based system to check for possible moves. We next evaluate the strength of the position of each player, which can be in the simplest manner done by assigning the values of each of the pieces on the board. Next, using the minimax algorithm, we explore the tree of possible moves to find the best next move. In this algorithm, the recursive tree of all possible moves is explored to a given depth, and the position is evaluated at the ending leaves of the tree. This method quickly becomes computationally demanding, so we will optimize it by the alpha-beta pruning algorithm. This algorithm stops evaluating a move when at least one of possible moves proves worse for the current player. Further improvements to this simple algorithm can be obtained by improving the evaluation function of the pieces. Here, the position of the pieces on the board is also taken into account. For example, a knight in the middle of the board has more possible moves and is thus more useful than a knight at the edge of the board. Other algorithms, such as the Monte Carlo tree search, have also been developed to improve the efficiency and help the computer play at a higher level. The next level of computer algorithms to play chess takes it one step further. In 2018, the AlphaZero program, developed by Google's DeepMind, achieved superhuman performance in chess by the use of reinforcement learning from self-play. It was given no domain knowledge except for the game rules. The game of chess is the longest studied game in the history of AI. Computers have now been able to play chess better than the best human players for more than 20 years. This has been made possible by the advances in processing power that allows a computer to evaluate the moves several rounds in advance with much more efficient way than a human. Today, there are even competitions where chess programs play among themselves. Nevertheless, chess is not considered a solved game. At the end of the unit, you'll find several questions to test your knowledge. Here is one of the questions. Why can a computer play chess better than a human? Is it because the computer code was written by a chess grandmaster? Or because a computer can evaluate several moves in advance in a faster and more efficient way than a human? Or because chess is a solved game and the computer will always win? Or because a human typically makes bad moves? Which one is it?